distributions aren't always symmetric. They can be skewed. So a symmetric distribution is one that's perfectly even on each side. It's a mirror image of itself on each side. And that means the mean will be equal to the median. If we have a symmetric distribution, then the mean will be equal to the median. They'll be the same number. Because that middle number is the one, it'll also be the mode in this case, but it'll be the one where 50% are above and 50% are below, and also it is the average value. That's a symmetric distribution. Distributions can be skewed. So if they're skewed like this, where a lot of the values are pushed towards the right, we would call that a negative skew. That would be a case where the mean is less than the median. If the mean is less than the median, then you have a negatively skewed distribution. So you can think of that negative as referring to the mean. The mean is below the median. It's a negative. We have to add a negative number to the median to get to the mean. So that's a negative skew. A positive skew would be a shift of the data in this direction, where things are kind of pushed over to the left. Here, the mean is greater than the median. So when the mean is greater than the median, that means you have a positively skewed distribution. Let's take a look at a couple of examples. So here's an example of a negatively skewed distribution, where the mean is less than the median. Death rate by age. Another thing worth noting that I want to point out is that this axis here is not linear. You can see it starts at 1, and then 2, and then 4, and then 8, and then 16. It's doubling each time. And so this is a logarithmic scale. So sometimes in order to present data so that we can kind of see the relative values a little more clearly, the logarithmic scale is better. But you can see that death is much more common at older ages. And so because of this, the mean is actually less than the median. That 50% of people fall below the median, but fewer than 50% fall below the mean. So the mean age for death is 73.7 years old, but the median age for death is 77.3 years old. So this is an example of a negative skewed distribution. An example of a positively skewed distribution where the mean is greater than the median would be income. So this is household income, and you can see that it's positively skewed. The data sort of pushed off to the left here, and that's because of some income inequality, that most people make a pretty typical average, or not necessarily average, but a typical income, and some people, few people, make really high incomes. And so those really high incomes, those pull our mean over to the right and mean that the mean is higher than the median, which is, kind of the more typical value. 50% of people would have incomes below this, and 50% would have incomes below this. But less than 50% have incomes above the mean income here because the distribution is positively skewed.